Okay, so I copied just the darts.c to darts-omp.c or yeah, and then I just changed the header there. But otherwise, like if we look at this, basically we're gonna be parallelizing the exact same thing that we were parallelizing previously, right? So there's not a lot of difference there except for the manner in which we're going to parallelize. Okay. So the first thing that we want to do is we want to include OMP.h. So that includes our OpenMP header files. Okay, so we're parallelizing this for loop here. And the thing that we need to do there is we just need to use OpenMP just around this loop only, right? This is actually going to be a pretty short parallelization. There's a couple of things we need to think about though when we're doing this. So we need to think about variable scope. That's one thing. Right, our LC generator.h is not thread safe. That's included in, there's a comment in there that says it's not thread safe. So we need to think about how we're going to make sure that it is thread safe, or that there's at least enough thread safety that we can do what we need to do with it. Yeah. So I guess let's think about these things for a little bit here. So this is a reduction, right? Right, because we're adding all these things into ncirc, right? So it's a reduction on the variable ncirc. Does everybody see that and agree with me? Does anybody disagree with me about that? No? Okay, that's good. So let's go back here in our slides and let's look at reduce. Okay, that's the first thing we should do. Here it is. Reduction. So we're using C, so this is the format of, this is the format of what we're going to do. So let's go ahead. Actually, better thing to do is to come over here and look at, not this one. There was another one that had a reduction in it. Somewhere. I thought there was one with a reduction. I guess not. Okay. Nope. Let's see that section. Okay. There's not one with a reduction in it. I thought there was. I thought I was going to make my life super easy.
Concept wise.
That's okay. Okay, so let's do this. So we're going to do pragma OMP parallel reduction. Am I right? Helen's here to tell me. And our variable that we're reducing on, we can find this reduction. No, that's the scheduling. Where did it go? Oh, because I'm trying to hurry.
Oops.
Oh, shoot, I'm sorry, I'm trying to hurry and then I'm totally missing it, of course.
33.
33, thank you. I just wanted to make sure I got my syntax right. So yeah, we just put a plus, right, because we're adding. So we just put a plus. And then the one that we are reducing on is ncirc.
I think it's a, what is the sentence?
Oh, it's a colon.
Colon.
Yes, thank you.
2 dots.
Thank you. This is why we have the expert here. Okay, so then we need to worry about variable scope, right? We need to worry about that. Because we defined X and Y up there, right? So by default, what are they gonna be? They're gonna be shared. We don't want them to be shared, right? If they're shared, then we'll run into troubles because what'll happen is, let's say I'm a thread, you're a thread. I calculate X and I decide that X equals 0.7, sure. And you calculate X. Oh, and so then I write that into X, right? You calculate X, you decide that X is 0.5. And then that's while I'm still calculating Y. Then I move on to that next line and I do X times X. It's your value of X, whereas it should be my value of X, right? Because you overwrote it. So I have your value of X and my value of Y that I'm computing in that next line, maybe. So anyway, that'll make everything wrong. So we definitely need to make sure that we have it as a private variable. So if we come down here and we look at our variable scopes and how we do these, you can see we're going to put private. So we want X and Y are definitely private. Is there anything else that we need to be private? We don't have to worry about R squared because that's a constant. Nobody's changing it, okay? But we do need to worry about whatever variables that we have there in LC generator, right? Because again, I don't want to overwrite my random number with your random number because then that's going to mess things up for me. I just happen to have another terminal open. So I'm just going to use it to look at LC generator so that I don't have to go in and out. Okay, so the ones that we have to really be concerned about are this random next and the random last, right? So I need those to be private for me. And you need your own private copies of those. We don't have to worry about these ones, multiplier, add-in, and pmod, because those never get altered, right? Those remain constant, so we don't really have to worry about them. Okay, so actually, let me check. Let me just look at this one more time. Random next, okay. But let's see about random last. So the only concern about random last is I'm not sure if we need it to be first private or no. No, we don't. Okay. Random last. Okay, now I don't like how this goes over like that, so I'm going to do this thing. There. Okay, so those, I believe those are the variables that we need to specify as being private. Does anybody have any thoughts about that? I'm hoping I'm gonna get some comments here that are gonna be insightful. How could it see inside LCG random? You're right, Mark. I think we don't need to do random next, but we do need random last. Because random last is like a global variable. And random next is created inside of LCG random. So yeah, you have a very good point. Thank you, sir. So I'm going to get rid of random next. Thank you. I think if I tried to compile that, it would probably give me an error if I had something in there that didn't exist. But basically with random last, the way, okay. The simple way to think of this is that when you do this pound include thing, it like just literally copies and pastes this into your code at the very top. Okay, that's kind of the way that I think of it. And then I'm able to imagine that therefore it would see random last because that's basically like a global variable at the very top of my code. Okay, but it's not, you're right, it's not going to see random next. So thank you for pointing that out to me. Any other comments or questions? Okay. Yeah, so if there is a variable that is created inside of the scope of a function that is called within a parallel section, then that is private by default.
Private, all right.
Yeah, so that's why this is private. But this is shared because it's a global variable that everyone already knows about going into our loop here. Okay, so
If random next was declared as static, would you run back into the same issue?
if random next was declared as static, would I run
Yeah.
into the same issue?
Would you still be okay with the scope, or would you now have to consider that? I'll figure it out. Thank you.
Yeah, okay, so I think you would still be okay. How you can tell me if I'm right or wrong.
Not do static, it's just scary.
Yeah, I mean, static is kind of scary, but I think you would probably still be okay.
That was why I kind of waved it off, because I thought, yeah, I should never do that. So I'll just not. All good.
No trouble.
Exactly, yeah, just do not do that. How about that? Okay, so this I think will work. Like this could be all that we have to do, except there is one problem. Anybody know what that problem is?
Yours.
So
One P parallel 4.
4, okay. Okay, well, that's a problem, thank you. OMP parallel 4 reduction? Yeah, okay, that I left out, thank you. No, I was thinking of another problem, okay. Okay, what do we got in our chat here? Yes, okay, somebody's missing 4, thank you, Barry. We need to specify the barrier. No. So I think we don't, because like the very next line here is the for loop. I don't think we need like the curly braces, do we?
No.
Okay, that's what I thought. But I'll tell you what I was thinking about, which is our good friend random last. right? So random last is going to be set to 0 for absolutely everyone, right? And when we did when we did it with MPI, we discovered that because random last is set to 0, then all of the threads are just, or the parallel processes are just going to be repeating the same random numbers, right? So this actually won't work. So I think we actually need, unfortunately, we actually need a line before we go into the reduction part, where we set random last. Yeah. So let me see if I can fix this. Okay, somebody has a comment. Do we need to specify the number of threads now? So Bowen, we could, but it's easier and better for us to just do it when we run the code. So that we can test it, you know, at different thread counts. Okay.
If the randomness function, going in and out is really, really quick, even doing it as a critical is fine.
Okay.
It's called like no congestion function. So say assuming each thread or getting to this function at different time and they each takes really fast,
I see. Okay.
it's okay to do the critical.
We can just do a critical there. I see. Okay. So did everybody hear what Helen said? She said, like, if LCG random was like really fast function, which it is, then we could just use critical there. We could like surround the generation of X and Y by a critical section.
Yeah, basically.
Yeah. But I think that as a general practice, we probably don't want to do that. Because that kind of ends the parallelism in a sense, right? Because they still only one at a time can do it. So then we've kind of just made it serial across multiple threads. So I think instead, here's what we need to do. So I'm going to use all of my elite VI skills. Pragma OMP parallel, and then I'm going to do this. I'm going to say those are my private variables for my parallel section. Okay, in this case, I am going to,
That's get thread num and do something.
yeah, that's exactly what I'm gonna do. I'm going to do this. So I have my whole parallel section kind of defined here, and then I'm gonna do let's see, and random last equals OMP get thread num. Yes. Okay, then I'm going into my for reduction. So I don't need the word parallel here anymore. Right. Oh. Oh, wait, sorry. Trying to get rid of the word. Okay, I don't know what just happened, but probably then I've got pragma OMP for reduction. And I don't need the privates, oops, because I already declared those, right? Oops. Okay, so I think that will do it. Does anybody have any comments? Gonna write it. Any other comments? I think we got it. Shall we try it and see? Let's just compile it and see. Oh, wait, somebody has a comment. Don't we need to change end circ? Actually, we don't, Mark. We don't need to change end circ at all. Because it is our, the reduction takes care of that. So when I say reduction and it's looking for the plus, you know, the add operator, it understands that that plus plus is an addition operator. And yeah, it's gonna be fine. It's gonna make it through. Mhm. Okay, so let's, oops. Too many little windows open. Okay, so. Am I here? What am I doing? I don't even know what I'm doing. Okay, there we go. So I saved that. Okay, now I'm going to CC. Okay, OpenMP is not enabled by default, I believe.
F OpenMP.
So yeah, -F OpenMP, that's the GNU. By default, we're in the GNU environment. -F OpenMP. Darts. -omp.c. O darts -omp. Let's see. Oh, it compiled. Okay. I'll call that a success. It compiled. Okay. So next, I am going to come back to my salloc here. I'm going to get my 30-minute allocation here. Perfect. Okay. And then I am going to give it a shot. So what I want to do is I want to export. Well, I guess I could just do this OMP. Let's see, export OMP num thread equals 1. Okay, we're going to start with 1, and then we're going to just run it. We don't actually need to use srun because we're not using MPI. And then I can just do darts OMP. Oh, whoops, I forgot to do dot slash. Okay, that actually looks like a familiar number. Do you all remember that number from when we did it in serial with MPI? We should be getting the same numbers. So let's go to oh, we got a different number. Huh. Yeah, we got a different number. So that should have been 3.142076. Okay, something is fishy here. Let's try 4. Yeah, okay. So we did something wrong, I think. Don't know what we did wrong, though. Yeah, okay. Yeah, we did something wrong. That's disappointing. Um, okay. Most of the time. Okay, you get random, that's right, random last. Is random last really the right thing? Yeah, random last, okay. Okay, I did something wrong, y'all, but I don't know what it is. Oh, what about I? Do you think I? Well, no, I is created there, right? So that should be okay.
I need to rerun it.
Okay. Anybody have something in the? Wow, Chris, I've never heard that one. Oh, I see. Okay, well, the thing about that, Chris, so he says using pragma OMP critical rands around the LCG random calls fixes it, and that's probably true. I don't doubt you. But the thing is, when you do that, then you're with critical, right? We're only allowing one thread at a time to do that. And so then effectively that becomes serial. So yes, that probably does fix it.
Doing X and Y was critical also works.
Yeah.
I feel like the random last is not. It's like one index apart. It's not num.
Well, yeah, we could do some debugging of this, I guess, because, I mean, obviously there's a problem. Don't know what it is. Okay, one new. Yeah, that is the example. Yes, I know.
So is the critical, is that basically adding like a mutex to the LCG random? Okay.
Yeah, that's basically what it does.
Definitely works.
Yeah, okay, I have done this before where I've made it work, this way without resorting to that. Let me think how to do it. Okay, let's do a little debugging. So this is always the risk with doing, live programming is you never know what's gonna happen. Okay, so I'm going to print f. Let's see. Hello from thread. And then what's it? D. Random last. Let's just see if that is correct. That is correctly. Yeah, let's just see if it's setting it correctly, because maybe that's the problem. I honestly don't know what the problem is. Okay, so let's try it again. Okay, we got that. Oh, hello from thread 0. Great, that worked. Oh, I should have put a line break, but okay, whatever. Beautiful, beautiful. For also. Yeah, okay. So look at, we were talking about the ordering, so we've got 0, 1, we've got 0, 1, 3, and 2. Okay, I am not clear on what is going on here. Oh shoot, I just accidentally did my screensaver. I'm not clear on what's happening here. I mean, could try those, but I don't think that's going to make any difference. Okay, I think I saw somebody had a comment. Let's see. Pi for n equals 4 is different from my last run. Oh, okay, good observation, Ted. So I got a different value. So that, I mean, that tells you, right, we've got some kind of race condition going on here. Yeah. Oh. What about n circ? Okay, I set it to be 0 out there. I'm just gonna check because I wonder if that could be a problem. If n circ got, okay, so first of all, let me just do this. oops, sorry. And, okay, I'm gonna put in a new line there. And then n circ equals %d. Let's just make sure that that got set correctly. It probably did, but
Oh, if you put n circ as,
I didn't put it as private. It should be,
reduction,
it's shared, right?
reduction means it's shared.
Just say it again, Helen. Should I
It's
explicitly?
in the reduction, clause, it means it's shared, but it's in reduction kind of way of shared.
Okay, so
It's
do I
not
need to put
exactly
it as,
private.
do I need to explicitly say it's shared in the,
Mm-mm.
in the OpenMP pragma here? Do I need to? Maybe I do. Shared. And circ. You think that'll help?
I don't think so.
You don't think so? Okay. Well, we'll just give it a shot anyway. What could I have done? No, it didn't, I mean, I got a different answer, but I'll probably get a different answer again if I run it like that. Yeah, you just get different answers because there's something wrong. Wow, okay, I'm kind of stumped. I'm kind of embarrassed, actually, that I didn't get this right. But that's kind of the joy of programming, what can I say?
So you say in your comment in your random number generator that it's not thread safe.
Mhm.
Would that not likely be where the race conditioning has happened? Because
That's-
you're
yeah.
returning the same random number for a lot of them?
Yeah, that is definitely where something is happening.
Okay.
Yeah, so I tried to mitigate that by making random last be private.
But that's just for the initialization. So that would break you away from there, right?
So what'll happen is, from here on out, like when we're in our parallel section, everyone has their own copy of random last. Right, so,
Right.
yeah, so what should happen here?
But there's not, that means they have their own copy, but it's not a mutex on the function call. So
That's true, but if you look at the function, the only thing that happens in the function is that random next, or sorry, this random next gets created, so that's also private by default. Then we do some multiplication and division and stuff. And then we reset random last, which is a private copy. So I don't know what is happening here. Because I think I have made it thread safe, okay, by making this thing be private, this random last. Random next doesn't need to be made private because it's gonna be private no matter what. Okay, so Isaac says, if you specify default none, remove random last from private, and comment out the random last initialization line, the compiler doesn't complain, so maybe it just isn't actually making it private. Huh. Interesting, Isaac. Okay, I will try specifying default none. Like you suggested here. Default none. And then, I know you said to, also comment out those other things, but let's see. Let's see what happens if we compile that, if it's gonna complain, probably, if it complains. Oh, okay, well, it's. Okay, so it wants me to specify, num trials. Note enclosing parallel. R2 not specified and enclosing parallel. Oh, I see, okay. So it wants me to do num trials and R2 as private, or as public, or, shared or private, whatever I want to do with it. Okay, let me. And then you were saying if I commented this out. And so I need to also come up here and do. I mean, I think we can have a shared R2. R2 and num trials. Okay, let's try that. And we'll see like if it complains, like you're saying. Yeah, it doesn't complain. Okay, so I think you're right. Somehow it is not making that private. It doesn't. Oh, wait, I still have it in that list though. Hey, okay. I'll get rid of it. Oh, because of my printf. Okay. Well, let me just get rid of my printf. Yeah, okay. So you're right. That tells us that it's not actually making that private. Interesting. Why would that be?
It's not private.
Anybody have any thoughts as to why that would be? Is there something in there about like global variables, do you know, Helen, like about making them private?
I'm also putting them as private, it's not working. My solution was using critical. Try this.
Okay, yeah, well, okay, so some of this is, we're a victim of this really terrible random number generator, so we could use a different random number generator. We could use MKL or some, we don't have MKL right now, do we? I don't remember. But we could use a different random number generator and we would get a lot better results anyway.
How about we comment out long random last equals 0 in the .h file, and then just define it in locally in the main function.
Oh, okay. I'll
I'm
try
not
that.
using it, but it's there in the global scope. That's
Okay. Sure, I'll try that. We could, okay, that's a really good point. So let's try
make
that.
it local here.
Okay.
In
Okay, and so then we could just do long random last.
yeah.
Yeah. Okay, and then we can add it back in here to Our private variables, random last. Okay, we may actually also need to put it here, right? Like, we just may need to, oh, sorry. Hold on one second. Sorry, y'all, I'm trying to save keystrokes. And then in here, yeah, we can just make. Okay, so we comment that out. And then we just put random last here, right here. Long random last. Okay, kind of changes the structure of it, but hopefully this ought to work. Okay, and then we can reset. Oops. I don't know where I am. Here we are. We can do this. And let's try it. Okay, it compiled. It's always good. Okay. Whoa, pi is equal to 4. Cool. I like that. Okay, so that made it totally wrong. Let's see what I did wrong. Oh, okay. I know what I did wrong. Okay. I know what I did wrong. Nope. And then in here, I'm going to do long star random last. Oh, shoot. Why am I not doing the right thing here? Star. Okay, I think that. Do we need like something here, like a star? Something like that. We'll find out. It'll tell me. That's what I like about the compiler. It always tells you when you're wrong. Oh, yeah. Invalid. Yeah. Right. Okay, that was my wrong. Star. And this should be star. Oh. Arg. Okay. So just making some random adjustments here, you all. Nothing to see here. Okay, well, it compiled. So now we'll try it again. Oh, look at that. Okay, that worked. That worked. And then 2. Okay, that looks like what we got from our other ones. Okay,
My
so
results.
yeah, so that was
Yeah, that
how
was
it
good.
it was not. When I put that in there, it did not actually make it private. Fascinating. Fascinating.
You show your slide, code again.
Sorry, what?
You show your code again.
My code? Yeah, sure. So my code is, this is darts. Okay, so I defined, what I had to do was I had to define random last up here. And then I had to send it through to LCG random so that it could be updated. Okay, so what this is this is the address of random last. This is the location where it is stored,
Choose that.
right?
Did you change the .h file?
Yes, I did. I had to make changes to the .h file.
Some of those things.
So the changes that I made here was, well, first of all, I commented that out. And then I had to add this as an argument to LCG random. And this star thingy, it's kind of confusing. I don't know why they use like a star here and they use like an ampersand like that, but this is like a pointer to random last, the variable.
So I have added this thing here. I should can actually comment this out, but anyway,
Yeah,
I didn't
you
see
can.
here, should comment out that, doesn't need. But in my, in here, I'm making it private. It's like defined here, but then
Uh-huh.
also private, that's why I get it here. In reduction. And
Okay. Does that need to be like last private,
no, just private.
just private?
I don't need this actually, right?
Right, yeah, I just wanna comment that out.
Just want to test it again. Like
Okay.
results closer, but it's always still different. Ten. Two. Not too bad.
I think that's what I got, yeah,
Yeah, it's not too bad. And 4 is like 14. So I
okay.
think I didn't use the.
You didn't use
these,
exactly my method
the
there, yeah.
address or the variables here. It basically define this thing here and then on the main program getting it private. So this is very similar, right?
Very similar. Mhm.
Output 1.4 is it once we get 3.14, it's close, it's good enough. 1.4.
Well,
It's
these should
closer.
actually, these should be, in theory,
Changing.
they should be identical to what you get with 4 MPI processes.
Okay. 140428. I think I remember this. Oh, this is 1.
That's 1, yeah.
So it should be always equal to 1.
No, so what I'm saying is like when we do srun of minus n4 of darts dash MPI, hopefully that is, yeah, see, I did this with OMP dump threads 4
and 4.
and
Oh,
srun
excellent.
4, and I got the same answer.
I like
So
yours,
my
yeah.
answer, my
Yes.
version there is correct,
Just
but
a little bit hard to change all these things. A lot of
yeah,
changes.
it had to make a
Mine
lot
has
of
less
changes
changes,
actually,
only
so
3, 5 to 4.
that kind of messed things up in a way. Okay, so we've got like 5 minutes left
That's good.
because we struggled with that one
Got it all good.
and we got it eventually. Okay, so you specify okay. Anyway, I could have sworn that I made it work before without resorting to all that crazy stuff and without using the
That this H file will be used by other functions.
yeah.
Me too, I changed my .h file.
Yeah. Yeah, so I thought I was able to do it without doing a critical and without making all those crazy changes before. So I guess that's something we need to look into for next year.
Let's use the critical as the thing, but work on the hybrid because
Yeah,
at least we got results, everything. That was in the solutions right now.
right, okay,
So
yeah,
that you-
so I guess since we have 4 minutes and I don't really want to keep people here forever, let's look at the solution for the OpenMP and MPI hybrid version. So let's see, if I do darts, oh. crash cars, Dart Suite, C, and Darts hybrid. Let's see. Okay, so this is a solution that I made, so numbers. So if we were gonna do this, this is how we would do it. So instead of MPI init, we would use MPI init thread. And then we would use like MPI thread multiple or anything that we wanted to use there. So we had to do this little thing to make sure that all of our trials were used, right? Just to, you know, give one person or a couple of them just one extra thing to do. Okay, pragma OMP parallel, pragma OMP for private reduction. Yeah, and so then I just used the OMP critical. I called this section randoms. But that's basically how you would do it. And then at the end you would do, you know, the reduce, just like we did with the collectives. Just do the reduce. And that would be it.